So what I'm going to go through is I'm going to go through a very short definition of vibration, what it's about and what you can find with it, and then get into our live demo, doing a demonstration of our onboard visualization tools, and then going into some of the more in-depth analysis tools that we have around. And finally, I'll give you a little bit of information about our approved training offering. So, vibration. The definition of vibration is oscillation about an equilibrium point. And what we have in this animation is a way of talking about some of the common terms. So here we have a simple mass spring system that everyone, I'm sure, is familiar with. The displacement is measured from the equilibrium point, so that's the middle. The displacement here is plotted as x, and then time on the x-axis, so our displacement x varies with time. And what we can see is that as the displacement varies with time, then so does the velocity, but the velocity is changing out of phase with the time, because if you think about the speed of the spring, it's going at its maximum speed as it goes through the equilibrium point. And then also you have the acceleration, which is going in the opposite direction to the displacement. So when the displacement is at one extreme, the acceleration is at its maximum, pulling the mass back in the other direction. And what we have is this whole cycle between kinetic energy and potential energy, the potential energy in the spring, the kinetic energy from the movement of the mass. And these oscillate between one another, providing a vibration. Now we use what's called simple harmonic motion as the simplification for vibration, and that means we can look at the vibration as a whole set of discrete frequencies. So what we see in real life is a much more complicated waveform, but what we can generally say is that we have a force and we have a response. And actually in real life, we'll have lots of forces at different frequencies due to different effects on the machines. And then we get a response, which is partly due to the machine rotor, partly due to the foundation it's built on, and all sorts of other stiffnesses and damping factors within there. So why is that useful to us? Well, within those patterns of frequencies, we can find a lot of different problems on machines. So anything that's related to the rotor, such as an imbalance or a misalignment, will come through in a relatively low frequency area. We also see that from rotor problems, bent shaft, cracked shafts, and also from any looseness in the foundation, that tends to come through in the low frequency area. And then when we think of things in the higher frequency area, things like rolling element bearing damage and gear damage, we get a series of impacts which come through at a much higher frequency. But these can all be picked out by vibration analysis, whereas in contrast to a lot of other analysis techniques, so for example, oil analysis is very good at picking up damaged bearings and damaged gears, but it can't do the unbalance and misalignment side of things. If you've got plain bearings, you can learn a lot from the bearing oil pressure, but obviously that excludes any machines with rolling element bearings. You can look at things like exhaust gas temperature, but that'll only tell you about your efficiency, really. So there's lots of different techniques out there for doing monitoring, but vibration is a very good all-rounder. It will tell you about a lot of different things. So this morning I'm going to do a short live demo in order to show what we have in our training facility for demonstrating this in real life when we're doing training, and also to show how our applications work for customers who want to apply these sorts of vibration techniques. So our control system, the controllers from Bachmann, can do a lot of the work near the machine. They're effectively edge devices. They can do all the vibration analysis close to the machine. But probably you don't want too deep an insight coming straight into your control room or your bridge or your engineers on site. On the ship, you want that data available for specialists to look at, but you want something a little more short term to keep you in the position of knowing what your machine's doing and collecting enough data to do more analysis if you need to. So we have these two areas that we're looking at. The CMS Visu runs on the controller, and it allows you to get some diagnostics and some alarms and watch what's going on with the vibration in real time. So this is set up on a system that's looking at our rig. You can see this morning I discovered that one of the sensors had fallen off, so I had to disconnect it while I got it glued back on. That was so that's that one. And then yesterday I was doing some practicing, so there was some readings triggered, and you just get alarm messages like this about the status of the measurement system and also any high readings that may come through. We have the diagnostic capabilities to tell you what's happening on the measurement system itself. If it's part of the control system, you see the whole control system there as well. And then in general, we have some controls as to show how the collection of the data is going on. But what we're interested in today is the trend data, which gives us the graphs of the vibration. So I shall just start up the rig, and if I go into one of the trends, we have here a selection of different yeah, here we are. We've started now. We've got our first measurement points coming in there. Then if I take the speed up a little, it gets a little bit noisy, I'm afraid. I hope you can still hear me. But we can see now we have more data points coming in, and we've got a higher vibration level because the machine's running at a higher speed. So this allows us to, the CMS Visu software can not only take a continuous reading, but it can also give different aspects. So this is the second acceleration. We've got two different filters. The first acceleration gives us a slightly different shape. We also have a velocity filter, which shows us lower frequency data. So you can see we get a continuous coming in. That data is stored. I'm afraid the noise is rather high, so I've switched the machine off now, as you'll have realized, and then the levels will show up again as coming back down to a lower level. So you see we've come back down again after that period. But what we can also do during this measurement is we can take a more detailed measurement, which creates a waveform from the vibration of the machine, and that measurement can then be sent off either off ship to a specialist on shore, or if you have a specialist on the ship, somebody at the ship can take it away and look at it in a more detailed system. We can also arrange if there's communications possible, even if that's only when the ship's in port, it's possible to have a monitoring service where the data gets transferred back to our team at Bachmann Monitoring, who can look at the vibrations for you and give an indication of what's going on. So what's happening in the background is the monitoring system is taking a detailed measurement from the machine every now and then, every hour or so, but you have these continuous overall levels showing what's going on with the machine, and you have continuous alarming. So if something suddenly changes and a vibration goes up, then an alarm will be triggered, and the system can take a sample of more detailed data from that point. So I have here a picture of our Weblog expert system. This is actually from the live system, and it's also looking at data from the training rig. So this is data on a previous run here, and you can see this is the same principle, that we get a point In this case, every few minutes, because it's from the test rig. On a real live situation, we'd probably go for once every hour or so for a detailed measurement point. And then we would take the trend of particular frequency bands in here. So this particular example relates to, if I can get it to show me, come on. There we are. So this relates to a ball pass frequency outer. So that means there's a defect on the outer race of the bearing. The bearing we have in this machine has got a defect built into it so that we can see this effect. So that's in the envelope spectrum, which is slightly more detailed analysis that's gone on there. But when we have a signal from a new signal coming in, and I've got one here that was transferred across earlier, because you don't want to be watching all the various transfer mechanisms. But we can take that signal directly into our source data, and then we have it here visible on the screen. And that file, if I just make that a little bit bigger so you can see it, we've got the time signal there. And actually the file contains all the channels from the test rig. So I can add in more channels, and you can see in certain channels these large spikes that are coming from our defect on the bearing. So we've got a lot of tools behind here, so we can put in the bearing frequencies. We've got cursors, we've got 3D waterfall plots, for example, which can help us to see what's going on, see how things are changing in time, and get into the detailed analysis of the data. So that's Weblog Expert. Just to say a little bit more about how that all goes through. If I go back to my earlier example, we have a series of different frequencies set up which relate to specific issues on a machine. They may be unbalance or misalignment, or there may be specific bearing problems or specific gearbox problems. And between those, we will get a number of these trends that come up. And then if any of these go into an alarm or an alert area, then we can go into a more detailed analysis and generate some information about what needs to be done to fix the machine before things go too badly wrong. So that's our more detailed package. It's very much process-based, so that if we have a lot of data to go through, we focus very quickly onto the data with the alarms coming up. So what you can see here is that all the different alarm messages that come in are related to a severity, and we can decide on that which one we're going to look at first, and it allows us to get through a lot of data in any given day. But then the tools behind it, the time signal analysis, the spectrum analysis, and the envelope spectra allow us to get into the details of what's going on the machine so that we can support predictive maintenance. So I shall switch back now into my slideshow. And just to say a little bit about vibration monitoring training. So I'm speaking today from the training facility in Rudolstadt, which has been set up over the last 12 months. It's been in use for about 6 months. Obviously, with the pandemic, we've not been able to do very much face-to-face training, but we can use it as a remote demonstration place as well. So we have our vibration rig that I showed you earlier. We do all our product training now from here, so we can do training on how Weblog is used, how it interacts with a machine, so that we can see how the data is collected. And so that's training on the use of Weblog for the analysis, and also the setup of all the vibration analysis facilities. But we don't just do training on products, we also do theory training about vibration. Now, you may be aware that the ISO standards committees on vibration monitoring set up the series of standards for condition monitoring and diagnostics of machines, requirements for qualification and assessment of personnel, or in other words, training. This is a set of standards which effectively shows how training should be done. It sets out syllabuses for things like vibration analysis, thermography, acoustic emissions, and a few other techniques as well. What we train on here is the part 2, vibration condition monitoring and diagnostics. So that training is based on the standard and the syllabus from the standard, but the standard requires that training organizations have a very strong quality system in place to ensure the quality of the training and that the content is correct. And there are actually external bodies who approve these training courses. So we have gone to the British Institute of Non-Destructive Testing, who do the approval, and they came and audited us and checked our notes and made sure we were following the syllabus and checked our processes and everything like that. So we have recently been approved as a approved training organization for vibration analysis. We actually started with a category 3 course for some of our internal people, which we ran last week. And so we will be making training available as part of our portfolio on categories 1, 2, and 3 for vibration analysis. We don't yet offer Cat 4, but we may do in the future if there is demand for it. What I should point out is that vibration, it's not a black art. It's quite a straightforward science, but it is a specialist subject, and there's quite a lot of different aspects of vibration that you need to know about in order to be able to go through a qualification to show that you are a trained vibration analyst. And it's not just vibration analysis, it also concerns the whole topic of condition monitoring and looking after and applying that within a maintenance strategy. So just to sum up, I gave you a very quick taste of the start point of a vibration discussion about defining vibration and defining some of the terms that go with that, and showed and mentioned how machine faults show up in different parts of the vibration signal. That amplitude that we get can also be used for machinery protection. And then in the demo, we went through the onboard visualization and then a little bit about some of the options for in-depth analysis. I should actually point out that our product training for Weblog for an expert user, Weblog expert, for the full training is more than a week to get. It's approximately a week for the analysis side of things, and it's approximately a week for the configuration side of things. So you can see it's quite a large product in there, which does a lot of in-depth things. And again, the specific training under the ISO standards, each training course is a week long because there are a lot of different topics to get through within that syllabus. So we've developed that approved training. We've been approved by BINDT, and so we're now available as a trainer for such courses and qualifications, and we'll be offering that as and when the demand requires another course to run. So that's me for today. So if you've got any questions, I'll be quite happy to take them up. And yeah, let's go from there.
Yeah, hello, David. I have a question.
Mm-hmm.
Yeah, thank you for the clear presentation and demo. Quick introduction about myself. Ralf Stam, working at automation company MSA Service. But I've also some experience in the condition monitoring field. And I was wondering, so you as Bachmann also have a remote monitoring center, so you supply customers with advice based on the vibrations, right?
That's right. Yes.
Yeah. I was wondering how do you communicate the results with the crew? Do you have like reporting systems or whatever, or is that there's some automation on it, or how do your advice come to the person who needs it, who needs to take action?
Okay, so the monitoring center here in Rudolstadt, we have a system which we call the Weblog portal, which is an internet-based system. So when we create an event report, we generate a short report highlighting the part of the machine with a problem, highlighting what we think the problem is, what needs to be done, and then that report is put into our ticket system and an email is sent automatically to the crew. Now, as you may know, our monitoring is not purely for the marine branch. And in fact, the majority of our customers at the moment are in the wind branch. I realize that access to an internet from a ship system may be a little bit more complex. So there may be other things we would need to do in order to put that in place. But clearly it's something that we can maybe work out through satellite mobile phone communications or something like that. It's a relatively simple portal to get onto, and it's driven through a simple email system. So I don't know, I have to admit, I don't know how emails work onto ships, but that's the basic delivery mechanism, but then all the information is available within the portal, and you can look through the history of the ticket and get back to your data as well.
Okay, thank you.
Maybe I can add one more thing to that, because in the past we have been connecting thrusters. There are two options here, that it's connected through the internet. As soon as a connection is made, the data is sent and the ticket is triggered. In the case the owner or class doesn't allow us to go directly on the internet, the data file is just stored on a USB stick and sent by hand per email into the ticket system. It just depends on how the owner wants it to be done.
Yeah, clear. Yeah, that's indeed also one of the hassles you need to fix when delivering this kind of service. Just that connection on the one side for the data coming through your analysts, and the other way back. So sending the advice and reports back. But
I completely agree with that. The key to a good condition monitoring system is good communications in both directions, because if you set up condition monitoring and find a few issues on a machine and just send off those issues and then never hear whether you were correct or whether you were too early or too late, then you can never improve your system. So the whole feedback allows continuous improvement.
Yeah, and that's also the training part of the training or the keeping good close contact with the person. Well, in this case, for a vessel, maybe for a windmill, it's different. But for a crew on a vessel, then it's key how they translate the advice into actions or not, or what they, because the analyst knows a lot from the graphs, etc. But not always that much from the process, how the machines are being used, and that cooperation is key to success.
Yeah, that's one of the advantages of the Bachmann system being embedded in the control system. It's relatively easy to bring in certain key parameters about loadings on the machines that you're looking at, speeds that they're running at. Obviously, we get anyway. But you can get more data from the background in order to learn more about the operating conditions and correlate with the operating conditions.
Yeah.
And the CMS Visu that I demonstrated earlier does have the capability of alarming on other parameters in the system rather than just one of the vibration parameters, and can tell you about what else is going on in the system. Haven't got that on the test rig, obviously, but it's available.
Yeah.
David, maybe we can ask one of the other attendees having experience. I see some of our customers using our systems. How do you process the data? How do you inform your customer or your own center, for example? Maybe I can ask this to Alexander Nijdek or to Jan Glas. Maybe they know.
Can you hear me?
Yes, we can hear you.
Perfect. Yeah. So yeah, it's in practical, it's a problem. Yeah, to keep the communication line always active. And yeah, I think the important thing beside the tools you get with, let me say, the weblog and so on, is also to have the internal processes that that you get regularly in touch with the customer, and you have also the correct contact person on customer side and so on. And when we are talking about a continuous monitoring, I think it's also important to have, let me say, some kind of agreement that this whole, let me say, monitoring process is defined. What are the responsibilities of each side? It's also a problem for us that we can receive the data. So we have also the described way. Okay, the customer needs to download to download the data on the USB stick and then to provide it to us. And this is something which has to be very clarified with the customer and regular lived in the practical operation. But it's difficult. Yes, I agree.
Thank you, Alex and Nidek, for helping us out here a little bit. I got a chat, David. We're still seeing your screen with all the faces and the topics. Maybe
okay.
you should.
Yeah, I'll stop sharing. Sorry. Yeah, there we are.
Yeah. Okay. Perfect. Now we see you. It's getting better.
Maybe I should switch my camera off as well, like everybody else.
Any more questions? Maybe I have one. Gert-Jan.
Yeah, I have one for David. Thank you. David, the training part is interesting for me. So you have a week part analysis and then a week configuration. That's both done in Rudolstadt, right? It's on the premises that you have the training, or is it also combined with some online elements?
We have been doing some online training during the pandemic, so we are moving towards online training for the weblog and the analysis and configuration training. What we find is that trying to do a full week-long training session via the internet, via these sorts of meetings, is not really very good either for the trainer or the trainee. So they've been split into sessions of about 3 hours each, going over specific topics, and maybe streamlining it a little bit as well. So we end up with about 10 3-hour sessions for a company.
And when you finalize a training, do you have like return days, or do you keep the participants together throughout the period after the training is finished, so they can exchange experiences or share ideas or insights? Or is it just, well, this is the training and then it's implementing?
So we tend to do our product training on an individual company basis, because each company has its own processes and procedures, and Weblog is designed to allow you to tailor your procedures to the way you go through the Weblog processes, so that things like the ticket system, different companies will have different requirements. So the product training we tend to keep to single companies at a time. So obviously those people are working with each other anyway. The accredited training, the ISO standard CAT 123, we've only just started with that training, and so far we've only done an internal training, but that is actually an excellent idea, that we should have a sort of a network of people who've gone through the training and who want to exchange experiences. That sounds like a very good idea, and I'll be looking into that for once we start getting more and more different people coming to us, because obviously sharing experience between different industries is also very valuable for condition monitoring. So thank you for that suggestion.
Well, you're welcome. I haven't introduced myself. I'm Gert-Jan Huijsen, co-founder of the LISA community, and that's all what the LISA community is about: sharing information and experiences and connecting the right people. So you have already the possibility within the Lisa community to connect some of the people and try to experiment with that. But we can take it up with Ronald if he likes. Thank you.
Yeah, this is our next step. So the first step today was to show a little bit of the tools we have. So the first tool David showed was our onboard visualization. Of course, you need to understand a little bit about the equipment. You never can identify if something is wrong if you don't know, have no reference to it. And I think it's a very good idea to involve the crew on board. These are the first stakeholders beside the machines who need to know what's going on in the machines. We would like to set up some kind of a training program on the Lisa community ourselves. Start dealing with the basics and see how we continue there. We'll come back to that. Are there any other questions from the audience?
Yes, Ronald.
Bert.
From me, Bert de Boer here, Air Quality. We have been talking about, or listening to the possibilities to analyze vibrations. My question is there already a form of event analysis in place in the system? So maybe, for instance, when a pressure pressure transmitter moves through a certain pressure path every so many times, which is not normal, or a pump switches on and off more than it would have to do in a normal situation. So all kind of related operational issues which could lead to damage or could be a sign of something not going well. That's the question. Is that clear or is that hazy?
Yeah, no, that's clear. The CMS Visu does have the capability of doing that. There is an alarm page on there which will. I showed it briefly during the demo, and it was just looking at some CMS-related alarms, but it can be related to operating conditions, specific thresholds being exceeded, and that doesn't have to just be it doesn't have to be a vibration. It could be a pressure, it could be temperature, and it will trigger the system to take an extra measurement, so it's got more data about what's going on, and it will generate an alarm that the crew can see.
Okay, so that's already in place also and working on other applications.
Yeah.
Okay.
That's one of the advantages of being built into a control system. There's a lot of opportunities to do that sort of thing.
Clear, thank you.
Ralph, I see you raise your hand.
Yeah, indeed. I had from the presentation a question for David. From the presentation, I understood that your software is also compatible with other condition monitoring hardware providers, and I was wondering, well, how that works. Is there some form of standardization maybe to exchange data, or how does that work together?
Yeah, unfortunately, that's one area that the manufacturers have never really got together on in terms of standardization of formats. We do, as Bachmann, offer what we call the Weblog Interface, which allows the conversion of data from other formats into the Weblog Expert system and the Weblog portal system. The way that works is we write a data converter running on the time signal from the other company's data, and then post-process that through and put it into the Weblog server, which holds all our data. Unfortunately, the vibration community has never really got together on having a single format for data. So virtually every system you buy has a slightly different data format behind it. Yeah. But the good news is most of the formats are quite simple to decode, so you can just read them into whatever your own system happens to work with. And I've worked with lots of systems in the past. My background was from the power industry, where we were doing vibration analysis on a single system from 5 or 6 different hardware types, all of which had completely different data formats. But it's not that difficult to bring them all into a single one, fortunately. So we're now developing that in the Weblog world, so the Weblog interface can take some raw data and post-process it into the same format that we use in our Weblog system.
Yeah,
And for example,
oh, sorry.
Sorry, go on.
Yeah, provided that the supplier of this equipment is open about their standard, their data, and that's, well, from my experience, not always the case. So they're sometimes protecting the data format or whatever, that which doesn't allow you in that case to fully integrate it into your solution or into the customer solution.
Well, that is true that some suppliers are more open than others. Bachmann's policy has always been to be pretty open about what we do. So we use a RIF to text format that is relatively well known in the signal processing community. But so far we've not had any major pushback from anybody about reading their data in. Most companies do provide some sort of data export facility. What they tend to protect is their data, is their methods of doing the post-processing. So what they want to protect is their special FFT routines, their envelope analysis, their spike analysis, their GSE peak or whatever they want to happen to use. Yeah. But we use an envelope process based on the raw signal that we're able to read from the that's output by the other systems. So we're not infringing any of the processing copyrights in that way.
Yeah. Okay. Thanks. Clear.
Thanks for that question, Ralph, and also for the comment, because this is sharing data is key, and it's key for both the OEM, for the ship owner, and for the shipyard to improve the quality of the systems. And that's a challenge, but we're still young.
Good.
Any other questions? Maybe I have one, David. What was wrong with the bearing? You showed us a lot of signals and points and envelope spectrums and so on, but what was actually wrong with the bearing?
So the bearing on our test rig, we've got a specific defect that's been machined in it. So to simulate a crack in a bearing race, there's been a notch machined in the outer race of the bearing. So what you saw on the
and how do you know this? By seeing the trend? Is this experience or?
Well, experience always does help, but I can just quickly show that graph again if I can find my share screen button. Yeah, if I just quickly go back to sharing the screen. So here, for example, you can see there's a lot of, I'll start from the time signal. So this is the actual vibration that you would feel, you would hear, and what you can see in particularly these traces from the affected bearing is there are a lot of spikes in the signal. And if I zoom into these spikes, what we have is a number of repeat impacts. So what we've got is there's been this notch machined in the outer race. So every time a rolling element goes over the notch, you get one of these impacts. Now, it's easy enough to see in the time signal we've got an impact at a certain interval, and then you can relate the interval to how often a roller goes past a defect on the outer race. But what we use in the Weblog Expert, which is used in this trend, is what we call an envelope spectrum, which is basically looking at the repeat frequencies of these impacts. I won't go into the processing here. We talk about that on the courses. But basically, you get this repeat frequency, and you can see here we've overlaid the frequency you would expect from the defect on the outer race on top of the envelope spectrum. So with a little bit of processing, we come very quickly to the frequency that points at what the defect actually is. And within the Weblog system itself, I can just make that a little bit bigger down the side. We can get a whole list of different frequencies relating to different problems. And then if we have an entire machine set up, we'll have those frequencies for every different bearing, different gears, different shafts. So we end up with many, many different frequencies to follow on a complex machine. And this is just a very short and quick way of getting to the one that's actually causing us the problem.
So being able to analyze in detail what's wrong with a bearing or a gearbox or something else, you need to know the details from this bearing. So if you go on the vessel, the crew, you can show the crew that there's something wrong, but because you don't know what kind of bearing is installed within that system, which is installed on board, you need to add this information to your data to be able to analyze what exactly is wrong.
That's right, yes. You would be able to say, oh, that's probably a bearing fault, but you wouldn't be able to say which bearing it was unless you had a list of the defect frequencies. So it's much easier after we've done this post-processing to extract those frequencies and compare them with a list of what we have as likely candidates.
So that also learns us that if we install such a system on board of the vessel, we can say there's something wrong with the bearing. And then if you are a specialist, a mechanic, you probably understand what's wrong. You can decide to order a new bearing and exactly the right one. And if you're not, you would call for help from shore, from your shore support, to identify what is exactly wrong in this equipment. Or is it even less specific that you don't know that there's a failure in the bearing, but maybe just a failure in the pump?
It would depend on the type of failure that you were looking at. So mostly with a rolling element bearing failure, you could probably say, yes, that's likely to be a rolling element bearing problem, but most systems have at least one bearing at each end, and sometimes they have two bearings at each end, one thrust bearing and one radial bearing. So you need to be able to distinguish between which bearing it actually is. And then if you have something like a gearbox, there'll maybe be 6, 8 bearings in a gearbox. So there's quite a lot of decisions to be made to find out the right bearing to change.
Okay. Any more questions from the audience?
No, I have again one.
Sure, Bert.
Is there a possibility to, how you say it in English, that the system is self-learning, that from a new situation, let's say, okay, the spectrum of this machine, when it's completely correct and new, looks like this, and that the system can recognize changes compared to the new situation?
We are certainly investigating those capabilities. It's not that straightforward to do. As you might imagine, it's quite an in-depth processing challenge to do that, especially with spectra, because for various reasons, a single spectrum doesn't come from a unique sort of time signal. So we can do some things along those lines, but mainly what we're doing in the Weblog system is picking out a narrow band frequency and using that to detect a specific fault frequency. We can apply the machine learning levels to those narrow band frequencies. We've also done a little bit about machine learning techniques to the overall values coming out of the vibration, but that's more of a anomaly detection, so it becomes easier and more sensitive to when something is changed, but it won't necessarily go to what's changed.
So there is some kind of machine learning capability in the system?
Not yet, but we're working on it. So we've got it in the background.
We can maybe give you a little bit more details later, but first I would like to give Olaf the floor. Is also a question. Is this Olaf?
Yes. Thank you. Yeah. And of course, Team Tech, we are located in Singapore. We are at the last stages of having a shaft power meter based on Bachmann's platform in the field. Actually, we hope starting sales in 2 or 3 months. It is for 2-stroke engines, David. So therefore, we talk about slide bearings, no roller bearings. With this shaft power meter, we also record the torsional vibrations of the shaft. And my question basically is, do you have some experience in this regard? Does it make sense to talk a little bit further? What can be found? How it can help operators in the marine with 2-stroke engines? What can be detected in addition to any unbalancing between the cylinders?
I'm sorry, your line wasn't terribly clear there, but I think I got the gist of it. You've got a power meter which takes the torque from the shaft from 2-stroke engines. So
Correct.
Clearly that's a very useful measurement to have. I think one of the things I pointed out early on is that vibration is popular because it does a lot of different things. But there's always a place as well for specific things like power meters on the shafts. So there will be certain items you can get from the power meter on the shaft, which are probably easier from the power meter on the shaft than they are from other from vibration signals.
We get the RPM, the rotation speed, also in a very high resolution. So therefore, torsional vibration analysis.
Yeah, the torsional vibration analysis is a different topic to the bodily vibration analysis because it's purely on the rotor, and it's an interesting topic and a useful topic, particularly if you've got certain failure modes that occur on your machine. So obviously on a propeller system, you may have certain failure modes regarding a natural frequency along the length of the propeller shaft and things like that. So our system would be able to read data from such meters and put it next to our vibration data so that everything could be brought together. So that can sometimes tell you about cause and effect. So an unbalanced shaft may have a higher torsional oscillation as well as a bodily vibration as well. So it's always useful to be able to bring different techniques together and look at things in the round and learn more about a machine. As we discussed in the earlier seminars, it's all about the failure modes and effects analysis so that you can identify the cost benefit from applying the right techniques in the right places. And if a shaft power meter is going to tell us something that's going to save us a lot of money, then that's going to be important to include in the whole condition monitoring system.
Okay.
I hope that answers the question.
Maybe I just go back to the question from Bet, because it all seems that combining a lot of information, a lot of data would help. And Bet was relating, I think, earlier to machine learning, and I would like to invite Jacco to say something about that, because actually we are thinking of this. A wind turbine is installed, is connected, so we can adjust all the parameters very easily. A vessel isn't. So Jacco, can you say something about your ideas here?
Yes, of course. Yeah, we have several ideas for this. So an idea could be that on the PLC where we are training a specific machine learning algorithm to take in to train it for a week on the data that's available on the controller. Then after that week, we check whether the system is changing from that machine learning model. So we have several machine learning techniques for that, and that's what we are currently looking into that, and we'll see what's the possibilities are there.
So as you're here, we are thinking of this specific also because of the nature of the vessels. We also think that everybody needs to prepare themselves a little bit better for maintenance purposes, so that we've learned from previous sessions that sometimes we look at the wrong bearings. So the first time to repair isn't always that successful. And installing such a machine learning addition could also prevent something like this happening. It's almost 11 o'clock now, so our hour is gone. It doesn't mean that you have to go, but for those who would like to go, I will give them the opportunity. I also want to ask in the group, is there, so most of you are already joining our premium members group within the LISA community. This is the place where we keep you informed and we keep you posted. On Friday within the LISA community, there's a very special day. It's the first year anniversary of the LISA community. And there's every 30 minutes, there's a new, let's say, walk-in session with all kinds of very interesting topics. We, as Bachmann, attend this as well. And one of the topics may relate a little bit to this, namely security on board of vessels, how to get your data without opening it up to all who want to use it for some other reasons. Would be interesting. Before we close this session, I would like to ask, is there any more question from your side? Does this answers the questions to the Smart Maintenance 2 event, showing what we can offer you on board and what we can offer you additional? I would like to thank you all. And I hope to see you at our next event. And this on smart maintenance will be on detailed on training, what we can offer you there. Okay, thank you for now. Who wants to stay is welcome. And then please share your questions.